Good morning, Honors Math 2 students. I'm sorry I am not here today, and I hope, again, you guys are so smart that you'll be able to figure this lesson out by the video. We are going to be do notes for 8.2, but first, before we do that, please get out your homework for 8.1, and either the sub can have you guys put in your groups like normal, and they can come pick it up, or you can send one person from each group up into the basket on the table right here by my doc cam and turn it in. Either way works for me. And so you guys shouldn't have any questions on that, I assume. I think you should be good. And so after that, please get out notes 8.2. And we're going to talk about inscribed angles. So let's just kind of recap what we talked about last time a little bit. So last time we talked about central angles. Central angles are angles at the center, hence the name, and around the whole center is 360 degrees, and around the whole outside of the circle is 360 degrees. But then you can have special angles that are called inscribed angles. And inscribed angles are not stopping at the center, but their vertex is on the edge of the circle. And so you can tell by this diagram that this angle is 60, which make this arc 60, but this angle that's going skinnier is 30 degrees. So we'll talk about that relationship. And for me, I do a lot of highlighting to see where the angle is going and what arc goes with it. So you don't have to use a highlighter, but you may want to use like a pen or something to help you trace. So I'm going to go on. There's a warm-up at the beginning of your notes. So if you're on notes 8.2, I put a warm-up of almost every lesson at the start. So I'm going to give you a couple minutes to talk about this in your groups. And I am going to tell you the answer once you guys have tried this. So I'll give you a few minutes to try this. And if you haven't turned in the homework, this is a good time to turn it in, or the sub to collect it while you're trying this. I'll give you a few minutes. So as you guys are finishing this up, remember that measure of arc, and a lot of times the M means you're going to put the answer as degrees, so that says measure of arc BCD. Remember, 3 letters means it's a major arc. So you have to go through, start at B, go through C, and go through D. Couple ways you can do that. But hopefully, if you check your answer, you got 290. Okay. Again, this is 34, so if you go 180 minus 34 degrees, that should give you 146. And so you can add 144 plus 146 to get 290. There are other ways to do it, but that's how I did it. Okay, let's go on. Okay, so a lot of vocabulary, and unfortunately my printer is going a little crazy, so some of this may be a little bit cut off. But it's on your notes. And angles whose vertex is on the circle and whose sides are chords. Okay, so I talked about chords a little bit. Chords are anything that goes across the circle from end to end. Has to not go past the circle. So AC is called a chord, and BC are called chords. So those are called chords. The diameter is a type of chord. And so if you have the 2 chords that stop at the edge of the circle, that's called an inscribed angle. And it intercepts an arc. So I think of it as big claws. And so like when you think of intercepting a football, you're catching it away from somebody, or you're grabbing it. This angle is grabbing that arc. That arc is called the intercepted arc. And with an arc with endpoints in the described angle, other points are interior of the angle. It is an intercepted arc. In the diagram, angle C intercepts arc AB. So that angle C intercepts arc AB. Angles formed by intersecting lines have a special relationship to the arcs the intersecting lines intercept. In this lesson, you will study the arcs inscribed. So this is the special relationship. Angle B If this is 60, like that I showed earlier, that is 30. It's always half of the intercepted arc. You can also think of the other way. The arc is twice as much as the angle. So we can also say that arc AC equals twice of angle B, either way. Okay? Now, it always doesn't look like that. The intercepted arc or the inscribed angle can go through the center. That's okay, because all you worry about is that the vertex is on the edge. It can go on either side of the center. Again, the vertex is on the edge, or it could be completely on one side of the, doesn't matter. Every time it's half of that arc, half of that arc, half of that arc. Super easy. Just remember last time was equal because it was in the center angle, but now it's half. Okay, so we're going to look at this question. Now, I'm not sure why it starts with this question, but there are no degrees here. And we want to find how much angle A is. Again, you might want to trace a lot. So here's angle A. And if I look at angle A, this is the intercepted arc. When I look at that, I see a semicircle. So this right here is 180 degrees. And remember, try to find semicircles. Try to find the diameter, which is that one. So angle A is half of 180, or angle A is 90 degrees. And these are all in degrees. They're all measures, so they're in degrees. Okay, so any angle that is intercepting the diameter, well, has the diameter in it and is intercepting a semicircle is going to be 90 degrees. Okay, let's go on to B. So this is where it gets tricky and you have to notice something. And there's something special relationship and there's a lot going on. We're going to find A, B, and C. So we're going to find the measure of angle A, the measure of angle B, the measure of angle C, and the measure of angle D. We're going to find all those. Okay, this is where the tracing is. I'm going to go to angle A. And I'm going to trace angle A right here. That's the angle. And I look, it goes from B, C to D. It actually has a major arc. And that major arc that it has is arc BCD, which is 190 degrees. So our answer would be half of 180 degrees, or 95 degrees. Helps if I do the math right. 95 degrees. I'm going to put that in there because I want to show you guys a relationship. Okay, now I need to find angle B. Well, angle B goes right here, and here's the chords that go with angle B, and it intercepts this right here. So it goes from A to D to C, so it should be half of arc ADC. And remember, we could write that ADC or CDA. And so it is half of 64 plus 90, which is 154, and half of 154 should be 77. So angle B is 77. Okay, I'm just going to keep tracing. Angle C goes from here, and it's hard because you can't see my colors very well from here. So it goes and should be half of arc BAD. And arc BAD is 106 plus 64, which is 170. So it's half of 170, which is 85. You're going to have to do this on a couple problems on your homework. So angle C is 85. Now, angle D, you could lot of options. You should know that all four angles of this are going to add up to be 360. So you can add what we have and subtract from 360, or you can figure out what angle D is. Okay? Well, angle D goes right here. These are the sides of it. This is the chord. This is the chord, so always find where the chords are. So it goes with this major arc, ABC, and ABC is 206, so it's half of 206, which is 103. Now, if you want to check, these are all going to add up to be 360. But what do you notice about the sum of the measures of the opposite angles? So what do you notice about the measure of angle B plus the measure of angle D? What do you notice the measure of angle A plus the measure of angle C? I'm going to tell you this is always true. So 77 plus 103, half of the whole 360, which is 180, and 95 plus 85 is the other half of the 360, which is 180. That is always going to be true. You need to remember that. Okay, so when you're done with that, turn the page. I know that this sentence is not on your paper. It is going to come up later. I'll show you guys on the next page where it comes up, but you might want to make a note of that. Okay, let's go to a couple more practice problems. Okay, so it says find the value of each variable for the circle. The dot represents the center. Okay, so well, none of these are in the center. Okay, so these are also inscribed angles, and we have to find A and B. Okay, well let's think about how. I can't know B without knowing A, and I can't know A without knowing B. So the easiest thing to do is find A first. I know that the whole circle adds up to be 360. I have 360 minus 142 right now. So I have 218 left. So A, arc A, has to equal 218 degrees. Try to use semicircles and full circles as much as you can. Now we know that B intercepts this arc. Again, I'm going to highlight this for you guys. That's where it catches. It's not the center angle, it's inscribed. So B should equal half of A. So B would be 109 degrees. Okay, now this is very, very important on a couple problems on your homework, and I would have you try it if I was here, but I'm not, so I'm just going to go through it with you guys. Okay, so let's start with somewhere we think would be easy. I would say either A or B, but let's just start alphabetically. So if I'm looking at A, here's angle A. It's not in the center. It's called inscribed because its vertex is on the edge. It intercepts this arc right here. So A should be half of that arc. And people get confused, like which one's smaller. Well, think about it. The angle is going skinny. It's smaller than that arc. Doesn't look the same. It looks skinnier than the arc. So angle A is 54 degrees. I'm going to put that in here so we don't forget. B should be really easy. How much is B? If you said 30, then you guys are right, because here's the intercepting arc, and that's half of 60, which is 30. Okay, now C. We would have a lot of discussions, and I'm kind of bummed I'm not here, about C if I was here, but hopefully you guys see, and you'll find different ways to find C later on in this chapter, that C and that C are vertical angles. They're the same. And hopefully you notice this is a triangle. And in that triangle, we have 54 plus 30, and we know that angles of a triangle add up to 180. So we're going to subtract that 84 we have from 180, and we get C is 96 degrees. So that means this is 96, which means this is 96. Big focus later on is we're going to find a different way to find that. Okay, so now in the middle of your page, and that, again, this is really important on a homework problem that you guys are going to do. Okay, in the middle of the page, you just find corollaries. And basically, corollaries are other things known now that you understand inscribed angles. Okay, so the most simple one is a corollary 1. If you have angle A and you have angle B, and they're intercepting the same arc, whatever that arc, those angles have to be the same. So let's say this is 100. Well, that's half of 100. And that's half of 100. They have to be equal. So they have to be congruent. Okay? This is from number 1. Anytime your angle is inscribed and your arc is 180 degrees or semicircle, then that angle C has to be 90 degrees. Has to be a right angle. And this is the one that everyone forgets, but this is the one I talked about on that example B. The opposite angles of a quadrilateral are always supplementary. So going back to that problem that I did earlier, we had, let me go backwards real quick. We had angle A was 95. No, it doesn't have to be 95. We had this was 85. It's a different picture, but you guys get the idea. 103 and 77. You can see those two add up to 180, these two. Now, they don't have to be those measures, but they always add up to 180. Okay? So those are called corollaries. They're in the middle of your page. They just are extra things. Okay? Okay, so let's use that corollary. And this is a strategy you don't have to use, but this is a strategy you can use if you don't have the diameter drawn in. You can draw it in. So this is kind of showing you don't have to use the strategy, but you can. They drew in a dotted line, which is called an auxiliary line, for the diameter. Why would that help? Well, then I know if this is 60, that would be 120 to make 180. And this is 80, this would be 100 degrees to make the other half of 180, and it makes it a little easier to find the angles. Okay, so let's talk about angle 1. Well, angle 1 stops at the diameter. It is going to be inscribed into a semicircle, so the measure of angle 1 is 90 degrees, half of that 180. Okay, angle 2. Okay, angle 2 goes from here. Again, you're going to do a lot of tracing. Here to here, which is all the way here. So it should be half of, because it's inscribed, 120 plus 100. So half of 220. So the measure of angle 2 is 110. Okay, and realize that this diameter may or may not cut that angle in half. We don't know that yet. Okay, now that we have that is 110 and this is 90, we should be able to figure out the other ones. I should know right now the measure of angle 3 is 90 degrees because opposite angles are supplementary, and then if you look, it's going to be in a semicircle. And then if that's 110, I should know that the measure of angle 4 is 70. Again, they're supplementary. But if you don't want to use that way, angle 4 goes to here. It goes all the way to that arc is 140. Half of 140 is 70. So either way. Again, you're going to want to trace a lot to help yourself. You don't have to draw an auxiliary line, but sometimes that helps. But only if you have a dot in the center. Okay, next couple things. We're going to go in through some pretty easy questions. And then we're going to talk about different types of inscribed angles that get people. Okay, again, I'd have you try this because this is super easy, but I'm hoping I'll highlight it. Angle X goes with a 72. Angle Y goes with a 72. That means they both have the same intercepting arc. So angle X and angle Y both have to be half of 72 or 36 degrees. They have to be the same. Okay, now we've got a lot going on number 4. Okay, I think the easiest place, not because it's alphabetically, but just because it's easy, I see this inscribed angle of 25 degrees. I tell you again, a vertex is at the edge. It's half of angle A, arc A. Doesn't mean arc A is 12.5. It means arc A is twice as much as 25. So A is 50 degrees. Always realize that the arcs are either equal or bigger than the angles, never vice versa. So we got 50 degrees here. Okay, another one that should be easy, or both of them, angle C and angle B, both intercept the semicircle. You see that their side, actually you can see their hypotenuse of our triangle is the diameter, so they are both 90 degrees. Okay. Okay, last thing. This one gets people, and so you guys know you will actually have a formula sheet on the test that has all these. So I know my printer's going a little crazy, but it says the following diagram shows a point A moving along the circle until it is tangent is formed. We'll talk about tangent in a second. From the inscribed angle theorem, you know that the first 3 diagrams, the angle A is half the measure of angle C. As the diagram suggests, that's also true when A and C collide. So we know, like if that's 100, that has to be 50. And if we move this kind of around, and now we move the A a little bit down, and that's still 100, the B and C are not moving, so you guys know the A is moving, still 50. Now I'm moving the A down farther. That's still 100. That's still 50. And now you do it so A and C are in the same exact spot. Again, we're not changing that arc, so that angle is still 50. So what happens is this is called a tangent. Okay, a tangent is a line that touches the circle in only one point. We'll actually go through that definition later. But that line is called a tangent, and it's still intercepting the same arc. So it doesn't matter if your angle starts poking out outside the circle, it still has the same arc. Okay, and that is basically what that's saying. That angle C is half of that arc, and angle C here is half that arc. Okay? Nothing different. Okay, so this diagram, I blew this up because it's really hard to understand, and a lot of people get this wrong. So angle X is this angle right here. Okay, let's start with something we know. So we have a 35 degrees here, and I see that that is the intercepted arc for the 35. So JL is your intercepting arc. So JL should be twice as much as 35, or 70 degrees. So this arc is 70 degrees. Okay? I should also know that angle J is 90 degrees. Okay? Because there's your diameter, so it's half of 180, which is 90. Now, X and Y is what we need to solve. Let's first start with X. So the X is the one that people get. So the X intercepts this arc. Okay? So there's the angle for angle X. LJK. LJK still intercepts that same arc. So X is still half of the arc. So X is 35 degrees. So this angle that's 35 intercepts JL, and also angle X intercepts JL. People really get confused by that. And then Y is in this triangle. So we have in that triangle 35 plus 90, which is 125. We subtract the 125 or 35 from either 125 from 180 or 35 from 90, and we get Y is 55 degrees. I'm going to show you why that makes sense. If you look at this intercepted arc, Y intercepts the arc QJ. I should know if this is 70, QJ is 110, and Y is half of 110. I like chapters like this, you guys could tell, where you can find the answer multiple ways. It says in part A, the inscribed angle Q, which is this one right here, and the angle formed by the tangent chord KJL, so KJL, intercept the same arc. What is always true? They're always congruent. We learned that from corollary 1. Okay, so we're going to use that to do this last 2 questions. Again, if I was here, I'd have you try these, but I'm not here. Okay, so a lot of things going on here. Let's say I want to find angle X, which is this angle right here. Okay, well, let's first of all use the 230 and find Y. You guys all should know that Y would be 130 degrees because we know the whole circle has to add up to be 360. So you don't have to go alphabetical order always. And then now angle X intercepts that arc. So X should be half of 130. So X is 65 degrees. Okay, that's one way to think about it. This number 6, surprisingly, is actually the exact same picture turned. This is 115, this angle. Okay, again, it's going all the way to the edge. So it's going all the way to the angle, not stopping at the circle. This intercepts this arc. So this arc should be twice as much as that angle, which is 230. Whoops, wow, same thing as here. And then I would know that F would be 130 because it's the rest of the circle. And E is the other intercepted arc or inscribed angle, and it should be half of 130, which is 65. I want to make one note to you guys. Do you notice that 115 and 65, these two angles, make 180 degrees together? Because they make a straight line. That is always going to be true. The two arcs are going to add to be 360. The two inscribed angles, if it's only two, are going to add up to be 180. Straight line. Okay, so hopefully you got that. It's a huge concept. The questions, there's a few tricky questions on your homework. I'm not going to lie. There's a few that are tricky. They're fun questions to do. I think they're fun questions to do. But they are kind of tricky. So if you guys are looking at them, let's see if I can grab the homework really quick. Please use the answer spots. People get really confused on number 5. Really think about what we learned about opposite angles equaling 180. That one gets really confusing for them. I will tell you that a lot of people miss this one. A ton. So be very careful on that. This is another one where you're going to use the opposite angles equal 180. So those two are pretty commonly missed. And these are going to be where the angles are kind of going outside the circle. Number 15, pretty commonly missed. Realize this is an isosceles triangle. It should make it easy. And number 16 is pretty commonly missed. Okay, we'll go over these on Wednesday and Thursday. But these are some of my favorite questions to do. So hopefully you guys do them good, and we can go over a lot of them on Wednesday and Thursday. Okay, have a great day. See you guys tomorrow or Thursday. Bye.